Hello friends, in this video I am going to cover the Java 8 most important questions and answers for the interview. And in this video I have included examples in each questions. Okay, so let's move to the question. Okay. Okay, so the very first question is like, what are the major features introduced in Java 8? So we know like in Java 8, several significant features were introduced. So like it was lambda expressions. So we know like lambda expression like anonymous functions that allow concise and functional style programming. Then functional interfaces. So interfaces with a single abstract method. Then a stream API was introduced for the processing of collections of elements. Then default methods in interfaces. Then method references. Then optional UI introduced in order to avoid a null pointer exception scenario. Then new date and time API were introduced, and then Nison JavaScript engine. So I have covered these questions in detail in the further question section. Okay, so the next question, like, what are lambda expressions? So we know like lambda expressions are a concise way to represent anonymous function. They enable you to treat functionality as a method argument or code as data. So lambda expression consists of parameters, an arrow, operator, and a body. So before lambda expression, we had anonymous classes, right? So suppose for runnable, we could add anonymous class in this way. We can write it something like this: runnable is equal to new runnable, and then inside that we could define this public void run method. So now with the introduction of lambda expression, same functionality can be written in just one line like this, like runnable lambda runnable is equal to, and then this double braces, and then arrow, and then the method. Next question is, what is functional interface? So a functional interface is again, so functional interface feature is again introduced in Java 8. So it's an interface that has only one abstract method. So it serves as the foundation for lambda expressions, allowing them to be assigned to functional interface instance. So if you want to create any new functional interfaces, you can simply annotate it at the rate of functional interface, even if you do not annotate, but if you have only one abstract method, so JVM will interpret it as a functional interface. And by using lambda expression, you can call it like this way. So here I have created one functional interface calculator with only one abstract method, that is calculate. So by using lambda expression like this, like calculator addition, and then we could pass two parameters with any name like AB, and here I have taken the AB, then arrow A plus B. Now the next feature is was introduced Stream API. So how does Stream API work? So Stream API provides a new abstraction for processing sequence of elements. Streams can be created from collections, from arrays, or IO channels. So they allow operations like filtering, mapping, and reduction to be performed on the elements in a concise and functional manner. Okay. So here, for example, I have taken the list of integers as numbers. So something like array.add list and numbers 1, 2, 3, 4, 5. And then I am taking the sum of all those integers which are event. Okay, so it can be done something like this: numbers.stream.filter, and then n modulo 2 is equal to 0, and then map to integer, the integer int value, and then sum. Okay, so it will return the sum of all the numbers which are event. So the next feature was default methods in Java 8. So what are default methods in Java 8? So default methods are methods with implementations within interfaces. So they allow you to add new methods to interfaces without breaking the classes that implement them. Okay. So this feature facilitates the enhancement of existing interfaces in a backward compatible way. What does it mean by the backward compatible way? It means like now if we add any new methods in our interface as default, so our existing classes which are implementing these interfaces, they will not get the compile time error. Okay, there will be no any compile time issue. So you can define default methods in this way, like interface shape. Here I have one abstract method, that is calculate area, and there is one default method. So default void display info, and it is displaying like this is a shape. So my class is implementing this interface. So here you can say in this class, like I have overridden only one method, that is calculate area, because that is abstract method. But for display info, I am not doing anything. But if I call this method display info on our class instance, so it will return us this is a shape. Okay, so I have not overridden this method in the interface. Now next question is, what are method references? So method differences provide a way to refer to methods without invoking them. So they can be used to simplify lambda expressions and make the code more readable. So there are 4 types of method differences: static, instance, constructor, and instance method on a particular object. So now let's see the example. So here again, we have list of string as names. So using lambda expression, we could do something like this: names.forEach, and for each name, we are printing system.out.println name. Okay. By using the method difference, we can do the same thing, but here you can see like I am only using the system.out and then 2 semicolon and println. I'm not specifically passing the name as a parameter. So again, it reduces the boilerplate code and it makes our code concise. Both are doing the same function. Next question is, what is the optional class in Java 8 and why was it introduced? So the optional class is a container that may or may not contain a non-null value. It is used to avoid dealing with the null differences, reducing the likelihood of null pointer exception. So before optional classes was introduced in Java 8, we had to check everywhere like whether the object is null or not, because if we are not checking the object null differences on the object, and if we are calling any method, so at runtime it might throw the null pointer exception scenario. Okay, so now we can avoid that scenario. So optional provides methods for checking the presence of a value and extracting it safely. So here, for example, I am taking the optional.hop nullable and get any name from database. So if name is present, then system.out.println name.get. If the name is not present, in that case we can return. Here I am simply printing that name not found, but you can do as per your functionality. Next question is, how does the new date and time API differ from the old date and calendar classes? So the new date and time API, it's in the java.time package, time API. So introduced in Java 8 is more intuitive and powerful compared to the old date and calendar classes. So these new classes like local date, local time, local date time, and zone date time that offer better control over date and time manipulations and eliminate many of the issues associated with the old API. So we know, like in our older date API, so we had to do a lot of we had to write a lot of functionality in order to change the different date formats. So we had to write the date format, or we had to do the parser date. So there was a lot of boilerplate code. Now, by introducing this new date time API, we can simply call these methods like local date now or local time now, and it will return us the desired format of date or time. The next question is, what is the Nashorn JavaScript engine in Java 8? So this Nashorn JavaScript engine is a modern JavaScript engine introduced in Java 8. So it allows Java applications to execute JavaScript code now natively. Okay, so it provides the improved performance for executing JavaScript within Java applications and can be used for embedding scripting capability. So now even the JavaScript code we can execute natively after introducing this feature in Java 8. So it is present in this javax.script engine, and it's present in the javax.script package. So for example, I have taken here, like you can see that script engine manager, and then I have taken the script engine by calling the manager.get engine by name, and then I have taken one string variable as JS code, and then I'm simply calling engine.eval and then passing this string. So it will return. So it will at runtime it will evaluate its value and return the value whatever value it is. Next question is, what is the for each method introduced in Java 8? So the for each method is introduced in the iterable interface in Java 8. It allows you to iterate through each element of a collection and perform an action on each element using a lambda expression on method differences. So before using this for each, so we had like extended for loop and simple for loop. So there you had there for iteration purpose it goes to the each element. So this is an enhanced version. Here it also do the same function, but the code is concise. You can simply do here like fruits.forEach, and then we are passing the lambda expression for fruit, and then arrow, and then system.out.println. So the code is very concise. Now we do not need to write a lot of codes. Next question is, how does the default keyword work in interfaces? So in Java 8, the default keyword is used to define a default implementation for a method in an interface. This allows existing interfaces to be enhanced with the new methods without breaking the implementing classes. So this question I had already covered earlier. So it's the same thing here. I'm also taking different examples like interface greetings. Here again, we have two methods. One is a default method and another is abstract method. So in our implementing class, I am only overriding this say hello, while for the default method, I am not doing anything until return the output. Next question is, what is the purpose of the map and filter operation in Stream API? So the map operation transforms each element of a stream using a provided function. And the filter operation filters element based on a condition defined by predicate function. So both operations are intermediate and largely evaluated. What the mean of largely evaluated? It means like they do not produce a final result until a terminal operation is invoked. Okay. So map is basically it maps your input into some other. It does the mapping on your input and produces some other output set. While the filter will do something like it will apply certain conditions and only those only in the output only those elements will come which will fulfill those conditions. So for example, here you can see that I am converting all my input string into the uppercase, and then finally I am collecting it as a list. So we can do something like this, that name.stream.map string to uppercase and then collect collectors.toList. And here I am filtering those names whose length is more than 3. So we can do something like name.stream.filter names.length greater than 3, and then we are collecting collectors.toList. Next question is, what are the peek and distinct methods in the Stream API used for? So the peek method allows you to perform an action on each element of the stream without affecting the stream's contents. Okay, it is useful mainly for a debugging purpose or logging purpose, while the distinct method is used to remove duplicate elements from the stream based on their equals method. So again, for example, here I have taken the list of integers as number, and I am doing the something numbers.stream.distinct.peek.count. So here for distinct, it will only return those elements which are distinct. So here it will return 1, 2, 3, 4, 5. And then for peek, I'm doing for this something, I'm printing those elements and then I'm counting. How can you handle exception in lambda expression? So we know like in lambda expression, there is no any exception, there is no any provision given for the exception handling. So lambda expression can't check the exception directly, okay? To handle exceptions, you can use a try catch block within the lambda body or wrap the lambda expression inside a method that declares the exception. Or alternatively, you can use functional interface that allow checked exceptions like java.util.functions or .function. Okay. So for example, you can see here. So I'm doing something like function integer square, and then inside the lambda expression, I am writing my own custom logic for the exception handling, try and then catch. So you can also do something like this. Next question is, how does the collectors class work in the Stream API? Okay, so the collectors class provides a set of static methods that allow you to accumulate elements from a stream into various data structure like lists, sets, and maps. So you would have seen my all examples. In the finally, I'm collecting by using the collectors.toList, collectors.toSet. So it has the method for the lists, sets, and maps. So these methods used in combination with the collect terminal operation to produce the desired result. Again, for example, you can see here names.stream.map.collect collectors.toList. So I'm getting the list of elements. It's returning me a list of element all the strings after mapping each element in the uppercase format, and then finally I'm collecting it. Here it's returning me the unique names as a set of a string. So here it's doing the collectors.toSet. Here it's returning us the in a format of map. So here it's doing the collectors.toMap, and it's taking name as a key and name.length as a value. Okay. So that's it, guys. So I have covered on this many questions. In the further video, I'll try to cover the more questions on the Java 8 features. So thank you very much. Thank you.